Imagine waking up in a fully connected smart home. The moment your alarm goes off, the thermostat adjusts the temperature, the lights slowly brighten, and the coffee maker starts brewing, all completely automatically. Every device is talking to a central hub to make your morning completely effortless. But that perfect convenience comes with a hidden catch. If a sudden thunderstorm rolls through and knocks out the neighborhood power grid, that highly advanced network instantly collapses. Your smart locks freeze, the screens go black, and you are left standing in the dark. In that exact moment, you don't need another smart device. You need a simple, reliable tool that doesn't care about the Wi-Fi or the power grid. You reach into a drawer for a battery-powered flashlight. For a long time, driving a ship across the ocean worked the same way. Navigators relied entirely on physical, analog instruments, brass compasses, mechanical steering columns, and printed paper charts that never spoke to one another. Today, however, a ship's bridge is a highly connected digital network. Guiding a massive cargo vessel safely through a storm relies on balancing these two exact ideas. A modern bridge is designed to maximize the incredible efficiency of a smart home network, while fiercely protecting the maritime equivalent of that flashlight in the drawer. We call the ship's network the integrated bridge system. When you are moving thousands of tons of steel through a crowded harbor, an officer simply doesn't have time to run around checking a dozen disconnected screens. They need one unified dashboard. That dashboard pulls information from several distinct sensors. First, there is the GPS receiver, which uses satellites to constantly calculate the ship's exact latitude and longitude on the Earth. Next is the marine radar. It bounces radio waves outward to detect the physical shapes of coastlines and nearby vessels, allowing the crew to see obstacles even in thick fog or the dead of night. But radar only gives you anonymous shapes. To solve that, the bridge uses the Automatic Identification System, or AIS. AIS broadcasts digital name tags, revealing exactly who those radar shapes are and where they're headed. Finally, ECDIS fuses this all together, placing your GPS, radar, and AIS data onto a single, live-updating electronic nautical chart. In a single glance, an officer can answer 3 critical questions. Where am I? What is around me? And who are they? In a high-stakes maneuver, having all that information in one place saves critical seconds. Connecting all these sensors creates a powerful tool, but it introduces a new risk. If a single sensor starts feeding bad data into that central map, the entire operational picture becomes a lie. To protect against this, ships use a principle called redundancy. Think of a bridge officer like a doctor. A good doctor doesn't diagnose a patient based on a single symptom. They cross-reference blood work, imaging, and a physical exam, looking for places where the tests agree, and more importantly, where they disagree. Imagine looking at a target vessel on your screen. The digital AIS name tag claims the vessel is stopped, but independent radar tracking shows it steadily moving toward you. When sensors argue like this, the system flags the anomaly, prompting the officer to investigate. In the past, navigators didn't have this luxury. An officer taking a reading with a sextant often had to trust that single, isolated measurement with the lives of everyone on board. Today, having multiple overlapping systems changes the job entirely. True mastery of a modern bridge means knowing how to spot and interpret disagreements between them. Even with cross-checking sensors, there is one scenario every crew prepares for: a total electrical blackout during a storm. If the ship loses power, the electronic charts, the radar, and the AIS all instantly die. To prevent a single failure from taking down everything at once, safety laws require a few specific tools to be physically and electrically disconnected. The most famous example is the magnetic compass. It remains a mandatory piece of equipment on even the most advanced ships, precisely because it requires zero electricity to find north. The same goes for communication. Ships carry an emergency beacon called an EPIRB. If the vessel sinks, rising water pressure triggers a mechanical spring. The beacon floats free and automatically transmits a distress signal to satellites, requiring no power from the ship. Integrating everyday instruments makes a ship incredibly efficient. But keeping the absolute most critical survival tools deliberately isolated is the only way to ensure you still have a working system when everything else goes dark. If you walk onto a modern ship's bridge for the very first time, it looks intimidating. It feels like an overwhelming wall of glowing buttons, dials, and technical acronyms. Everything in this room falls into 3 clear categories. Those 3 groups are the high-precision tools that integrate data, the second-opinion tools that cross-check for errors, and the flashlights waiting in the dark for an emergency. Applying this mindset is how an officer can confidently guide a massive cargo vessel through hazardous conditions, heavy traffic, and turbulent seas. Genuine bridge mastery comes from managing this system of systems, knowing how they connect to make the ship smarter and how they separate to keep it safe.